Hello, this is my Physics 2211 Lab 5. So we're going over just introductions of physics concepts, to track your video and data, or model code, compare the data, and then look at some possible sources of error, answer some additional questions. So for my lab, I picked an astronaut jumping on the moon, and we're going to use this data from Tracker, which gives us our what the actual constant is, and then compare that to a model to see um, if we can find what the gravitational constant of the moon is. So our physics principles, our Newton's second law, and then our update formulas. And then the outcome is that we set the system as the astronaut. We plug in different values of G and compare these values to tracker data. And then the closest G value found is close to the actual value of the moon, which is pretty cool. So Newton's second law, just classic dp/dt. And then our position update formula and our velocity update formula. We've gone over these many times this year. We're not going to dwell too much on them. So our tracker video data, so this is the video. Just get it right there. So we have 21 data points, FPS 30 seconds, just to record the video. So our initial position is right here. The only thing that really matters is the Y. And then also our initial velocity is 0 because we actually don't start, even though I did track the beginning, the actual graphs are only going to show it from right about here at Y top. And then this is our change in time from Y top, and then our system of the astronaut and our surroundings of the moon. So when we go to the model code, this is borrowed from some of the prior labs we did, along with a couple edits as well. So the astronaut initialized and get our graphs initialized. Put the mass as 160, which is an estimate. So we take the initial position. Again, all that matters is the Y for the code. And then the astronaut dot velocity. And then we take our time and our delta t. Our G is the number that we can choose to set. And then here's our actual loop. So we have our vector of the gravity right here, force gravity, which is also FNet. Our two update formulas with the values plugged in. Delta t. This is to print this stuff, and then I'll print our data. So when we take our data from the model and the tracker, we actually see that the blue, orange, and red are all from tracker, and then green, are from the model, and then green is from the tracker data. So you see we have these different values. So we know the blue one is 2. We know red is 1, so it's not really close to the red. Orange is 1.5, and blue is 2. And if we actually see the real data is in between those two numbers. And in reality, the gravity of the moon is actually 1.62. You can Google this, which means this is very close. It's most likely not perfect, which is to be expected. But that's pretty cool to see. So we actually look at some possible sources of error. It could be tracker imprecision, that the placement of the center mass is just not 100% constant. Just the video is very grainy, and also I definitely did not click in the 100% same constant spot of the astronaut every time. And then some values are assumed. Like I said, the mass of the astronaut was an assumption. We just kind of took that based on the average mass of the spacesuit. Then height is most likely not perfect. Since we're kind of looking at from a distance, we did have to also guess what that was in tracker. So to answer some additional questions, there's some fun ones. What if the moon landing was fake? Now, obviously, all of us moon truthers out there, we know it was fake. But in reality, this wouldn't make much sense. So how could we actually make this happen? Well, to produce this effect on the video, we'd have to have some string pulling up on the person, which would decrease their acceleration to be that of what the moon's actually is. And then we would also have to account for air resistance, which makes this extremely difficult. And then what does this mean? Well, the moon landing was probably not faked unless, most likely this is not actually possible to fake this, just because you would need ridiculous preparation. You have to account for all these things. You'd also have to have lasers to produce the light, just things that don't make much sense. And something with tracker, you could, if this was fake, you could probably use tracker to disprove it very easily, even with something, not that advanced. So sorry all my moon truthers out there. The moon landing is probably not faked. I highly recommend you try this lab as well if you want to have some fun. So thank you for watching.